So we want to make this look like a sum formula of sine. Okay. Now, you know trig ratio cannot be greater than 1 or less than 1, right? It has to be a fraction. So if a and b are whole numbers, there's no way we can express this as a cosine and as a sine. There's no way we can do that. So the correct number to factor out is always a squared plus b squared square root. Now what's the interpretation of that? Here's the interpretation. If one of the legs, or if this is a, right? So we're talking about, we want to express that as a cosine of some theta, right? So let's call that phi. I know that a should go down here because this is a cosine ratio and always refers to the adjacent over hypotenuse, right? Okay, so if I factor that out, that means this is going to be a squared plus b squared, right? And always, 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 what's going to be this one? B. So it matches. What's sine of this same angle? B over this ratio, right? So if I factor out a squared plus b squared, so we have a over this. And this is b over this. Do you see how this, if this were to be cosine of phi, this will always be the sine of phi? Because it's from the same triangle. So this will always work. Okay? So this is going to be expressed as a squared plus b squared. And it's essentially sine of theta, cosine of phi, plus cosine of theta and sine of phi. So we can always do this. So look, I didn't even pick a number. I just picked two random expressions, a and b. And with it, I was able to convert it into just pure one sine. So of course we can do this with every single numbers.